Area between two curves. In the previous session, we learned how to find the area between a curve using integration. Now, in this session, we'll be learning area between two different curves. Now, suppose you have a curve which is like this and another one which is going like this. So you can see that there is an area which is between these two, that is, this is that particular area. To find out this area, how can we do that using integration is what we are going to learn. So let's complete this graph. So you have the x-axis over here and the y-axis. And now I can see that this area, that is the green shaded area, is enclosed by two different graphs. And these two different graphs are intersecting at two different points also, right? So our main aim is to find the intersection points. So in any question you are asked to find out the area between two curves, find the intersection points. Very, very important. So when you find out the intersection point, suppose this intersection point over here is A comma B and this is C comma D. Now if I draw a vertical line, this will meet at A comma 0 and this one will meet at C comma 0. So our main first aim is to find out the intersection point between the two curves. Once I have found out the intersection points, suppose this function is y is equal to f of x and this graph under the one which is equal to y is equal to g of x. So you have two graphs like that. And these two are intersecting and giving me this one, right? Now how will I find this area which is in between this f of x and g of x? What I should do? Suppose instead of both f of x and g of x, I am drawing only f of x. So if my graph is looking only like this, which is the upper one, so this is from what? A to B. Now using the normal integration, how can you find out the area of this one? That is integral A to B f of x dx, right? Simple. This gives us this entire area. Yes. Now the lower one, which is y is equal to g of x, which is from this point A to B. Now what will be the area? This one will be having an area that is integral A to B g of x dx. So you have an area, the white one which I shaded over here, that is integral A to B f of x dx, and the green one that I shaded over here, integral A to B g of x dx. Now you can see that here this graph over here is a combination of these two graphs, right? So if I draw that again, you have a graph like this. So this shaded area is a combination of f of x and g of x, and it is not completely f of x and completely g of x. It is something which is different from these two. What is the difference? F of x is giving you the entire area because f of x is the upper one. It is giving an entire area down that. G of x slightly down, so it is giving an area which is slightly lesser than f of x. So that means to find out the area in between, this area which is in between these two, I just have to take integral A to B f of x minus g of x dx. Understood? So to find out the area between two different curves, always take the integral A to B, the upper curve minus the lower curve. Remember, upper curve with respect to the axis you are taking. Here I am taking with respect to the x-axis. Since I am taking with respect to the x-axis, the upper curve here is y is equal to f of x and the lower curve is y is equal to g of x. So since it is with respect to the x-axis, take it like that, you will get it as integral A to B f of x dx minus integral A to B g of x dx. Understood? So that is how you find out this entire area of this graph. Now, suppose if it is with respect to the y-axis, if it is like this, you have a curve like this. So this is the curve and this intersection point here it is A and this intersection point here it is B. So here if I have to find out this area, this shaded area, this is from A to B, but what is the upper curve? This is y is equal to f of x and this is y is equal to g of x. The upper curve now here is g of x. You can see that this is the upper curve because this one is giving this entire area, right? So if I take that as the upper curve, the area should be integral A to B g of x dx minus f of x dx. Is that right? It is wrong, entirely wrong. It is not with respect to x. Here I'm taking with respect to y. So this cannot be the area. So what should be the area? Integral A to B instead of g of x, you have to find it as g of y minus f of y dy. So if you do this with respect to y, you will be getting the area which is under the graph y is equal to g of x and y is equal to f of x. Understood? So either you can take with respect to the x-axis as well as you can take with respect to the y-axis also. So always make sure you find out the intersection points, and then using the intersection points, take the integral a to b and then the upper curve minus the lower curve. Suppose you have something which is like this. So you have a curve over here like this and then another one like this. So the upper one, so the pink one over here, I'm naming it as y is equal to f of x, and the green one, it is y is equal to g of x. And this intersection point here, it is a comma 0. This one over here, it is b comma 0, and this one over here is c comma 0 in the x-axis. Now how to find the area between these two? That is, what is this area over here and this one? So you can see that in the first case, that is the first limit from a to b over here, the upper curve is the pink one and the lower curve is the green one, right? Yes. So to find out this area, you have to take integral a to b, the upper curve f of x minus the lower curve g of x dx. Done? Yes. Plus, there is another area which is a smaller area, but in that case, the upper curve is the green one and this, that is g of x, and the lower curve is the pink one, which is f of x. So here in that case, here it is not from a to b, here it is from b to c, g of x minus f of x dx. So this gives us the area under this graph, where you have for some part an upper curve becomes a lower curve, and same happens for the pink one as well as the green curves over here. So here in this case, you just have to take these intersection points, and now after finding the intersection points, put it over here and get the final area which is bounded by these two curves. Understood? Now let's do some questions to understand how to find the area using the way that we just studied, that is area under two curves. So the first question over here is to find the area of the region bounded by the curves y is equal to x square and x is equal to y square. So you have two parabolas, right? So you have two parabolas. So let's draw the graph of this one. So we have y is equal to x square, which will be a graph like this, which is touching the origin. And there is another one which is x is equal to y square. So what will be this one? So this will be x is equal to y square. So you have over here y is equal to x square and x is equal to y square. So I told you to find out this area, the white one is y is equal to x square and the pink one is y square is equal to x. Find the intersection points. If y is equal to x square and x is equal to y square, you can say that I can put all this inside here, that is x is equal to y square, right? Or x square is equal to y. So I can say y is equal to x square, and if I square this thing, I will be getting x square is equal to y raised to 4. So I can put x square and this one, x square is equal to y and y raised to 4. So I can say y is equal to y raised to 4, or y raised to 4 minus y is equal to 0, or y into y cube minus 1 is equal to 0. So I can say y is equal to 0 or 1. So if y value is 0 or 1, what is x value? X value is same as what? 0 and 1. So 0, 0 is a point which is here in the origin. And what will be this point over here, this intersection? It will be 1, 1. So this intersection is 1. So if I draw a vertical line, this will be 1, 0. So to find out this area, I have to take integral 0 to 1, from 0 to 1. Upper curve, that is y square is equal to x. So if y square is equal to x, the upper curve, what is y? It will be root x. So I can take it as root x dx minus the lower curve, y is equal to x square. So x square dx, right? So x root x dx and x square dx. So what is the integral of root x dx? Root x integral will be 2 by 3 x raised to 3 by 2 from 0 to 1, minus x square integral will be x cube by 3 from 0 to 1. So this will give us the answer 2 by 3 minus 1 by 3, and that will be nothing but 1 by 3 units. So what is the area which is between the two parabolas y is equal to x square and x is equal to y square? It is nothing but 1 by 3 square units. Understood? So if we used the integration and found out the area between these two curves. Now the next one, tricky question, find the area of a triangle. You have a triangle whose vertices are 1, 0, 2, 2 and 3, 1. How can you find out the area of a triangle using integration? Just let's look at that. So you have 1, 0. So let's mark 1, 0 over here. So 1, 0, I'm marking it here. Then you have 2, 2. 2, 2 will be somewhere here. And then you have 3, 1. 3, 1 will be somewhere here. So if I join all these things, I will be getting a triangle, right? So I got a triangle over here when I joined all the points. So I joined all the points and I got a triangle. Now what is this area of the triangle? So to find out the area of this triangle, what I'm going to do here is I'm just going to draw a dotted line over here and here. And I'm marking this as A, this as B and this as C. So you can see that this point over here is 2, 0 and this coordinate over here will be 3, 0. So from 1, 0 to 2, 0 there is a curve, there is a straight line. There is another curve from 2, 0 to 3, 0, there is another line which is BC. And then from 1, 0 to 3, 0 there is a completely new line which is AC. So how to find the area between these points ABC? So if I write like this, that is from 1 to 2, if I write AB dx, plus from 2 to 3, if I write BC dx, and then from 1 to 3, if I subtract AC dx, will I be getting the entire area of the triangle? Look, if I take AB, the area which is shaded will be this thing. Yes, so that will be AB. Now if I take the integral under BC, I will be getting this entire area. Now if I take the area under AC, I will be getting this one down here. So you can see that if I add AB and BC's area and then subtract AC's area, I should be getting the area of the triangle ABC. Yes, yes. So this way I can find out the area of the triangle ABC. But before that, I need the equation of AB, BC and AC. Very important. So let's find out the equation of AB. So to find out the equation of the AB, you have 1, 0 and 2, 2. So use 2-point form, y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. So y minus 0 by y2 minus 0, that is 2 minus 0, 2 is equal to x minus 1 by 2 minus 1. So you will be getting it as y is equal to 2x minus 2. So this will be the first equation of AB. The second one, equation of BC, same way, 3, 1 and 2, 2. So you will be getting it as y minus 1 by 2 minus 1, 1 is equal to x minus 3 by x2 minus, that is 2 minus 3, that is minus 1. So you will be getting that equation as y minus 1 is equal to minus x plus 3, or y is equal to, from that you will be getting as minus x plus 4. So this will be the equation of the second line, that is BC. Understood? Now the third line, that is AC, equation of AC. So to find out the equation of AC, from 1, 0 to 3, 1, you will be having y minus 1 by 0 minus 1, that is minus 1, is equal to x minus 3 by 1 minus 3, that is minus 2. So these two gets cancelled and you have y is equal to x by 2 minus 3 by 2 plus 1, and that is x by 2 minus 1 by 2. So this gives us the equation of the third line AC. So you have the equations in terms of y of AB, of BC and now of AC also. Now you know the limits also where to apply, right? So from 1 to 2 AB, 2 to 3 BC and minus 1 to 3 AC. So putting all that, I'll just put it over here. So this is the equation of AC. So you have over here 1 to 2 AB. What is AB? 2x minus 2. So 2x minus 2 dx plus 2 to 3 BC. What is BC equation? Minus x plus 4. So minus x plus 4 dx minus 1 to 3 AC. What is AC? X by 2 minus 1 by 2 dx. So using all that, final calculation, do it and you will be getting the entire area of this triangle. So 2x minus 2, the integral will be x square minus 2x from 1 to 2 plus minus x, the integral will be x minus x square by 2 plus 4x from 2 to 3 minus this is x square by 4 minus x by 2 from 1 to 3. And when you do that, you will be getting x square minus 2x. When you put the upper limit, you will be getting 4 minus 4 minus 1 minus 2. And when you put 3, you will be getting minus 9 by 2 plus 12 minus 2 square by 2 plus 8 minus then you have 3 square by 4, that is 9 by 4 minus 3 by 2, and then you have minus 1 by 4 minus 1 by 2. So that is what we get here. Now for the further calculations, let's take this to the next page. And now 4 minus 4 is 0 gone. Yeah. Then minus 1 minus 2 is minus 1. So there is a minus outside. So that is 1 plus you have a minus out in inside. So that will be minus 9 by 2 plus 12. Then you have minus 2 square by 2. Minus 2 square by 2 is minus 2. Then you have a minus outside. So it will become plus 2. Then you have minus 8. Then you have minus 9 by 4. Then you have plus 3 by 2. And we have over here plus 1 by 4 minus 1 by 2. And now you have over here 1 plus 12, 13, 13 plus 2, 15, 15 minus 8 is 7. So 7 minus 9 by 2 plus 3 by 2 is minus 6 by 2. Minus 6 by 2 minus 1 by 2 is minus 7 by 2. Yes. And then you have minus 9 by 4 plus 1 by 4, that is minus 8 by 4. So you have 7 minus 7 by 2, that is 7 by 2, minus 8 by 4, that is 2. So 7 by 2 minus 2, that is 7 minus 4 by 2, or that gives us 3 by 2 square units. So this gives us the entire area of our triangle. So now we have used integration and also found out the area of what? Under two curves. That is, in the first case, we found out the area of two parabolas. And now we found out area of a triangle by using the same method, that is area under two curves. There are many other questions also which can come up here. That is, from parabolas, it can be a circle and another ellipse, a circle and a parabola, two circles, two parabolas, two ellipses, a circle and a line, two lines, three lines, maybe more. So these are different questions which can be asked from area under two curves. So in this whole session and in the previous one, we have discussed how to find the area using integration. I hope all this was very useful to you, and you should be learning how to solve, and you should be now able to solve questions which are of the form to find out the area which is under a single curve or two or three curves also. Now for the time being, let's just summarize this session.
Manorama Horizon. Learning made simple.